Without further ado, we'll now like to move on to our presentations. We'll now like to firstly invite our speakers, Dr. Denis Burnham and Ms. Marina Kalashnikova, to present. Dr. Denis Burnham, after getting his PhD and a junior faculty position at Monash University, then later at UNSW, Dr. Burnham was one of the first Australians to conduct research on infant speech perception. After his appointment as founding director of Mark's Institute for Brain, Behaviour and Development at Western Sydney University in 1999, he has been developing his research on experiential and inherited influences in speech and language development. Dr. Marina Kalashnikova joined the Mark's Institute in 2013 as a postdoctoral fellow and holds the positions of researcher in infancy studies and Mark's Baby Lab leader. Her work includes investigating perceptual and linguistic development in infants and children who are at risk for developing sensory or cognitive impairments. Their presentation is on the seeds of literacy, the earliest indicators of reading ability. Now let us put our hands together for our speakers.
Thank you very much for that kind invitation, and thank you for being here. I found the conference, it's only just started, but I found it extremely interesting and erudite. I'm going to talk about some early indications of dyslexia and reading ability, and talk about some research that we've been doing. So this is work with Denis, Burnham and myself and Marina Kalashnikova, but also with Usha Goswami, who's at Cambridge University in the UK. So starting with speech and literacy, human speech perception emerged quite a long time ago. So human infants perceive consonant contrast categorically. So if you have ba and a pa, young human infants will actually perceive these as separate sounds and perceive them categorically. So even a phonetic variation within those, they'll perceive those as consonant classes. But so do chinchillas, the little furry animals that people used to make coats out of, I think. And also macaque monkeys perceive the same things. So this suggests that our speech apparatus is not peculiar to us. Another interesting aspect is that
erwtensoep met worst is nog steeds een favoriete gerecht.
Human infants perceive, discriminate Dutch from, that was Dutch just then, from Japanese. Okay, so human infants will do that, but if it's played backwards, so that's Dutch and Japanese played backwards. When they play them backwards, they don't discriminate. And cotton-top tamarin monkeys do exactly the same thing. So the point I'm trying to make here is that chillas, macaque monkeys, tamarins have similar auditory hardware as humans. Okay, but we know that chillas and tamarins and macaque monkeys don't have human speech. So we've done something special to use this hardware for linguistic ends. Moving on to reading, literacy, writing emerged quite recently compared to speech perception, but it took a long time to develop, and it developed in at least 3 different places, and no one person invented writing. So there's various forms of writing that developed over many years until finally alphabetic and ideographic systems emerged. So the concept of speech represented by graphic code is not an obvious one. But no one person said, oh, let's invent writing. It took a long time, a long history for that to happen. So learning to read has little or no phylogenetic evolutionary history, but there is a long phylogenetic history for speech perception. Reading requires explicit instruction. If we put a child in a room full of books, they won't learn to read unless they have instruction. But if we put a child in a room full of people speaking, they will eventually learn to speak. So reading must be taught, but we believe that reading does rely on speech perception, this older ability that we have, and that the seeds of literacy, as we call it, lie in tuning speech perception to the surrounding ambient environment, or the different language environments, which is especially the case in Singapore, of course. So, look at evidence for the perceptual narrowing. Newborn infants' speech perception, they perceive, we think, all of the sounds in the world's languages. And these are based on auditory thresholds, a bit like the macaque monkeys or the chinchillas, okay, when the infants are first born. But then, around about 6 months, or maybe a bit earlier, there's perceptual narrowing. So, discrimination performance for non-native speech sounds that aren't in the languages that the child hearing around them, gets worse, while the perception of native speech sounds that are heard around them, gets better. So, for example, in English, infants' perception of a native sound, like what I played before, ba, pa, is maintained, whereas discrimination between two sounds that might be used in Hindi or in Thai, like ba, ba, okay, which are perceived as the same in English, infants originally perceive those differences, English language infants originally perceive those, but later on don't. So if we look at native versus non-native speech perception, infants' ability on native speech perception versus non-native speech perception tells us how much they're focusing on their own language. Okay, so this is an index of them focusing on their own language. And a study that we did some time ago with 4-year-olds, 6-year-olds and 8-year-olds, where the red is the native contrast, the green is the non-native contrast. We found that this happens in infancy, but also in children. This perceptual narrowing intensifies around about 6 years of age. Now, we all know what happens at 6 years of age. Children in most societies are taught to learn to read. So there's this peak in native versus non-native, peak in focus on native sounds, and when we did tests of reading and all sorts of other tests, we found that children with better focus on native sounds and disregarding non-native sounds were actually better readers. So this focus, which is established right in infancy, predicts or is related to reading ability. So, to summarise, perceptual narrowing occurs in infancy, there's further perceptual narrowing at reading onset, there's better perceptual narrowing, and better perceptual narrowing assists in reading acquisition. So there's a link between infant speech perception and literacy. Perceptual narrowing is also proportional to cognitive development. In an object search task, children who have better perceptual narrowing are also better at searching for objects, which is taken as an early sign of cognitive development. So the question arises, what happens for infants or children who are at risk for dyslexia? So let's look at indicators of dyslexia in infancy. We all know, I don't need to tell you that what dyslexia is, and that the incidence around the world is, around 10%. Depends on the country, etc., and the diagnosis procedures. But if a child's at genetic risk for dyslexia by having at least one dyslexic parent, then the incidence is much higher, somewhere between 35 and 60%. So dyslexia is not usually diagnosed or noticed, as we heard before about the wait to fail idea. Are there any early indicators of dyslexia? We know that infants who have a dyslexic parent are at risk for dyslexia, but is that shown in early infancy? So first of all, there's a study done by Christine Kitamura some time ago, and if you can follow this here, this is a native, this is where you play a sound to an infant over and over and over again, and if you play a native contrast like fa versus the, okay, then when you play the new sound, if you play fa, 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 and then fa, 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 when you play the new sound, the infant will attend more, okay, because they get habituated to the other one. But if you play them non-native sounds, these Indian Salish sounds from northwest North America, ki and ki, they don't discriminate those, okay? Oops, sorry. However, when we look at infants at risk for dyslexia, they do discriminate these non-native sounds. Okay, so these are infants between 6 and 12 months of age. They do discriminate these non-native sounds, whereas infants that are not at risk for dyslexia don't discriminate those non-native sounds. So there's no narrowing for non-native sounds at 10 to 12 months for infants at risk for dyslexia. And when you look at the correlations between parents' pseudo-word learning, word reading, spelling, etc., these are correlated with infants' discrimination of the non-native sound, but not Raven's matrices, which is a measure of intelligence. So it seems like there's some sort of there's something happening in infancy with infants at risk for dyslexia. There's also other evidence now that newborns at risk for dyslexia have inferior detection of vowel length and consonant length, and so these are newborns, and 2 to 6 month olds do also, and that there's also some hemispheric differences in newborn evoked potentials in syllable processing. So it seems like in infancy, all infants at genetic risk for dyslexia have deficits in auditory processing and early phonological skills, and that's regardless of whether later their auditory processing skills manifest as dyslexia, because we know that only 35 to 60% will manifest as dyslexia, but all infants, it seems, have these auditory processing abilities. So we think that the seeds of literacy lie in the tuning of speech perception to the ambient language environment. So this is the project that we embarked on about 5 years ago, Seeds of Literacy project. It's a 5-year Australian Research Council project. I won't go through all the tests here. There's a number of tests that we're doing, and I can report on those at different times. What I'm going to report on now is 2 of these in particular: the rise time an acoustic measure of infants' ability, and speech input, or infant-directed speech, how parents speak to infants. Okay, so I'm going to give you the results so far for rise time thresholds in infants at risk for dyslexia or not at risk for dyslexia, and also infant-directed speech by parents talking to infants at risk for dyslexia or not at risk for dyslexia. So hopefully we can pick up this audio. Sorry. Okay, so rise time is the time it takes for a sound to get to maximum amplitude. So if you look at the little diagram here, this one has a 15 millisecond rise time, and this one has a 200 millisecond rise time. This one takes a lot longer to get to the maximum amplitude. I'll play these sounds to you. So that has a very sharp attack. This sound here has a slower attack. And just to compare the two, starting off with the 15 and the 200, the short one and then the long one. If you're not dyslexic, you should hear the difference. Okay. If you are, you may or may not hear the difference. Okay. So we did this with young infants. There's some evidence from Usha Goswami's work that children with dyslexia have worse rise time thresholds. They have lower sensitivity to rise time, and this is related to their poorer phonological awareness as well. 3.5-year-old children who are at risk for dyslexia have lower sensitivity to rise time than not at risk for dyslexia, and that these deficits in auditory rise time processing result in problems in perceiving speech rhythm, prosodic structure, phonology and reading. So what about rise time in infants? Well, we devised a method for looking at this, for getting their thresholds. I won't go into great detail now, but it mainly requires infants to look at, they have a choice of listening to an alternating sound, like the 15 and the 300, 15, 300, or a repeating sound, okay? So this is on two sides. If they look to this side, they hear 15, 15, 15, 15. If they look to this side, they hear 15, 300, 15, 300. The 15, 300 will be more interesting if they can tell the difference. Okay, so we measure how long they look to each side to listen to those sounds, and then we adjust the sounds up or down to get a threshold. Okay, I can tell you more about that later. I won't go into too much detail now. So these are the infant's rise time thresholds. So a higher score means it's more difficult for the infant to discriminate between those sounds. So these are 7-month-olds and 10-month-olds. The blue is the not at risk infants, red is at risk infants. So infants at risk for dyslexia have more difficulty discriminating rise time than not at risk infants. Okay, so just hold on to that thought for a little while. This suggests that all infants at genetic risk for dyslexia, some have some deficits in rise time processing, because this was all of the infants we tested at this group result. So what about environmental factors? Well, the one factor that we've done a lot of work on, even prior to our work on dyslexia, is infant-directed speech. It used to be called motherese, that's now politically incorrect, and we found that motherese or infant-directed speech occurs when mothers talk to infants, when fathers talk to infants, even when 7-year-olds, 5-year-olds or 3-year-olds talk to infants. And it goes something, in English it goes something like, hello there my little duck, oh yes, aren't you good, beautiful, oh yeah, lovely girl, that sort of thing. So it's that sort of speech, right? Often poo-pooed in the literature or in the media for saying, oh, we don't want to talk to our children like that because they won't learn to speak properly. But we found that it's highly beneficial. So one particular measure that's really interesting is that in infant-directed speech, mothers and fathers and even little kids stretch out their vowels and they make them more discriminable, easier to discriminate between. And it doesn't matter whether it's English or Swedish or Russian or Mandarin, they stretch out the vowels. And in fact, in Mandarin and Cantonese, we have some information, some evidence that they stretch out the tones in Mandarin and Cantonese. So vowel hyperarticulation also facilitates language acquisition. There's been studies that have found that. So we looked at vowel hyperarticulation in infants not at risk for dyslexia, and just very quickly, the black triangle is talking to an adult, the red triangles are talking to an infant at 9 months or the same infants at 11 months. So the red triangles are bigger, so there's vowel hyperarticulation there in talking to not at risk infants. Talking to at-risk infants for dyslexia, infants at risk for dyslexia, there's no hyperarticulation. The mothers don't stretch out the vowels. Now, infants could be at risk for dyslexia because their mother's dyslexic, or they could be at risk for dyslexia because their father is dyslexic. So maybe it's just something that the mothers who are dyslexic are doing with their infants. But when we looked at the infants whose mothers were dyslexic versus those who weren't dyslexic, we found the same results. So what we think is that the lack of vowel hyperarticulation is a response to something from the infant. And we've got other evidence to back that up. I can tell you about it at some other stage. So they're responding to something in the infant. And this goes in with my story of saying, that all infants at risk for dyslexia have some sort of auditory processing deficit. Look at the correlations between mother's hyperarticulation and infants' thresholds, response thresholds. There's a high correlation between mother's hyperarticulation at 9 months and infants' thresholds at 10 months. And that includes not just the infants at risk for dyslexia, but all the infants who are not at risk for dyslexia as well. So it seems like there's an intimate relationship between infants' ability to discriminate these rise times, which is an indicator of later dyslexia perhaps, and mother's hyperarticulation. Those who are worse at discriminating the thresholds have mothers who hyperarticulate less. Okay? So it suggests that vowel hyperarticulation by mothers and fathers, etc., and infants' auditory processing are strongly related. So just in conclusion, all infants at risk for dyslexia have auditory processing difficulties. I'm being quite black and white about this. I mean, there's a fair bit of evidence, but we probably need a lot more on this. Infants at risk for dyslexia have difficulty discriminating rise time. Mothers of infants at risk for dyslexia do not hyperarticulate vowels. Mother's degree of hyperarticulation is negatively related to infants' auditory processing ability, and that goes for infants at risk for dyslexia and those not at risk for dyslexia. And we think that infants' at-risk status drives the mother's behaviour. So maybe, let's think about this not negatively, but maybe something good is happening here. Maybe we know that the infants are very good at telling parents and kids and their older siblings the things that they want, like they're hungry or they're wet or whatever. We think this happens in cognitive abilities as well. So maybe this drive, what the infant is telling the parent is something good, okay? Don't hyperarticulate, because that's not going to help me. Maybe the infant is trying to tell the parent to do something else, and that's what we're investigating more. There might be less hyperarticulation, but the infant's behaviour may be encouraging the mother to engage in other behaviour that is beneficial for the infants. And that's what we're trying to work out with looking at videos of mothers talking to infants, etc., now. And so I'll be able to report on that sometime soon. Thank you.
Thank you, Dr. Denis, for the insightful presentation. We'd now like to invite Ms. Fanny Fu, Director of Learning Centres and Outreach, to present a token of appreciation to our speaker.